Hi everybody, this is section 9.1, the start of chapter 9. Chapter 9 is all about systems of equations, just like we had in 4.3, except we are going to be extending them over to 3 variables with 3 equations. Now we're going to hate these because they're super long for one thing. There's so many places that you can make an error for another that you might get frustrated with these. So, you know, I've only done 5, which I know doesn't seem like a lot. In the next section also, there's only 5. I think 4.3 only had, what, 5 or 7 or something like that. So your homework is down as far as numbers, but this might be a more frustrating section. So this particular section, 9.1, we're going to be looking at, using elimination to solve. 9.2, we're going to be doing matrices to solve, and then we're going to look at more matrices stuff in 9.3. So just like in section 4.3, we're looking for an x and a y that worked in both of the equations. And now we're looking for an x, a y, and a z that work in all 3 of these equations at the same time. Okay? Here we have these no solution, infinitely many solutions, and none of these I have chosen, so they all do have solutions to them. Okay? I'm not going to do these. All right, so let's get started, shall we? We have x plus 3y plus 4z equals 32. And then we have minus x plus y plus 2z is 4. Okay, so now your first step is to choose any 2 equations and drop a variable. Doesn't matter which 2 you choose, and it doesn't matter which variable you choose. So I've randomly chosen the first and the second, and I'm going to add these 2 so that my x's drop. Do you see that? And that's just random. Doesn't matter. There's always an easier way. And once you do a million of these, you'll find that easy way. So x minus x is gone, so that's my goal, is to get rid of that. I have 3y's plus y is 4y. 4z's and 2z's is 6z's. And 32 and 4 is 36. Okay? So now I've eliminated a variable, so now I've got another equation with just 2 variables, which I know how to deal with. I just did those in 4.3. So now I've chosen, okay, so my first step was to choose any 2 equations and drop a variable. Now I'm going to pick any other 2 equations, so I can pick the second and the third or the first and the third, but I have to drop the same variable. So I'm going to choose the second and the third. And I'm going to choose to drop x. If I add these, they're going to drop. My z's are also going to drop, which is makes this an easier problem. So I think the first 2 are like this, and then the back 3 are not. So we're going to start out with some easier problems where we have a double drop here, and when they double drop, then it makes it much easier. All right, so let's add. We got a negative x and an x for no x's. We've got y plus y for 2 y's. 2z's and negative 2z's are gone. Those are also dropped, and we're going to add the 4 and the 8 for a 12. Well, now I've got a single variable, so I can solve. Divide both sides by 2, so y is 6. Okay? Now I'm going to go back here into my, what was that? I just pushed something on my, how do I get over there? Darn it. Darn it, darn it, darn it. Okay, can I do it? Undo? No. Okay, hang on. I'll be right back. Okay, sorry about that. I don't know what the heck I hit there. I've got this stylus pen that has buttons on it, and I don't know what they're for. So obviously one of them is to do that. All right, so y is equal, I'm going to try this again without screwing up here. Y is equal to 6, so I'm going to put that in this one right here. Okay, just like I did before. in 4.3. So I've got 4 times 6 plus 6z is equal to 36. So now I've eliminated my double variable of y and z, and I've got just the z, and I can solve that. So now I can take 4 times 6 for 24 plus 6z is equal to 36. I'm going to subtract my 24 across. This is gone, so I've got 6z is equal to 12. So z is equal to 2. I'm going to divide this side by 6 and this side by 6. So far I've got 2 answers. All right. Now I'm going to go into any one of these 3 original and plug in my y, which is 6, and my z, which is 2, and find my x. So I'm just going to randomly pick this last one here. So I'm going to write down what I have. This is my last equation. I could have picked any of the 3. I don't know x. I know y is 6. And I know z is 2. And now again, I've got that single variable. That's my goal. So I've got x plus 6 minus 2 times 2 is 4. Okay, so 6 minus 4 is 2. And then I can subtract my 2 across. So I have x is equal to 6. So I've got 6, 6, and 2. Well, let's check those. They have to work. I'm only going to check one of these because this is going to take way too long, but you can check each one of them. So I'm going to take the first equation. I'm going to insert all my answers. So it says x plus 3y plus 4z is equal to 32. X is 6. Y is 6. Z is 2. So we have 6 plus 18 plus 8 is 32. Let's check that on the calculator. Okay. 6 plus 18 plus 8 gives me 32. Okay, so this one works. Let me do it 2 more times. The next one says minus x plus y plus 2z equals 4. So I'm going to take the opposite of 6 plus 6 plus 2 times 2, and that has to equal 4. All right, 6 plus 6, excuse me, negative 6 plus 6 is 0. So this is just 4 equals 4. So that's true. That one works as well. So let's try the last one. We have x plus 2, no, y minus 2z equals 8. So we would have 6 plus 6 minus 2 times 2 is 8. Well, then we have 6 plus 6 minus 4 is 8. We have 12 minus 4 is 8. So that one works as well. So it does work. So we're going to put this in as an ordered pair, ordered triplet, 6, 6, 2. Okay? 6, 6, 2. The order matters greatly. This is your x, your y, and your z. Okay? Well done. All right. Here's another one. I think this is another double drop. So let's take these first 2 equations here and drop my z terms. See how they're the same number? They're both a 1, but they're opposite signs, so they're going to drop nicely. I'm going to get a 2 for 1 in here because my y terms are also going to drop. Take the easiness while you can. So I'm going to stack these. And I'm going to add them. 2x and 2x is 4x. My y's and my z's are gone. 9 and 11 is 20, right? I'm going to actually solve for x. I'm going to divide both sides by 4. So x is 5. One answer. Now I'm going to take any other 2. So I'm going to take either the bottom 2 or the first and the third, and I'm going to add those. But I have to drop. What do I have to drop here? I have to drop my y terms, don't I? Okay, so if I take my second and my third and I write them over here, I add these. See how my y terms are going to drop? Right here. So 2x and x are 3x. These are gone. Minus z and a minus z is minus 2z. 11 and 0 is 11. So I've dropped, over here I've dropped y and z, so I have to choose one of those to drop over here. So I chose to drop my y term. So now I'm going to take this 5 and put it in right here and solve for z. Okay? Whenever I know what a variable is, I put it in and I solve. Okay, so I put the 5 in here. This is 15. I subtract 15 from this side. So I have minus 2z left over here. And 11 minus 15 is a negative 4, right? Think of, I had $11, I spent 15, so now I'm 4 in the hole. I want to divide through by negative 2 both sides. So z is 2. Here's another answer. Okay, now I want to find y. So I'm going to go back to any one of these 3 original equations. Okay, I'm just going to pick randomly the second one. Now that one's the hardest one, Simone. I'm going to randomly pick the first one. It really doesn't matter. Think easy. Okay, I know x, I know z, I can find y. X is 5. Oh, that was my phone. Sorry about that. I usually turn that off. Catchy little tune though, huh? Plus y plus z is equal to 9. So now I have 10 plus y plus 2, which is z. The 2's and the z's are going to really mess us up, aren't they? Equals 9. So I have 10 and 2 for 12 plus y is equal to 9. So I'm going to subtract my 12 across. This is really good practice as far as solving goes. So y is equal to a negative 3. So we have our solution, 5, negative 3, and 2. So we have 5, negative 3, and 2. Good job. Okay, so these aren't so bad because you've always got this first one here that you choose, and you've got that double drop. We dropped our z's and our y's. Okay, so now these here aren't going to be, I don't think these are a double drop. No, they're not. Nope. Okay. So let's start. I'm going to do all 5 of these for you because I think we need the practice. Now, if you need more practice, you know, you can always go into the textbook, you can do the odd problems, and you can work on those. All the answers are in the back of the book. Or when you're done with this, you can keep hitting similar exercise and get more of these. It doesn't affect your grade, okay? So you have to choose how many of these bad boys you want to do because they are bad. All right, so I've got my first and my second. If I added those, my z's would drop. Oops, looking good. So I'm going to do that. I'm going to stack these and add them. So I'm just going to randomly pick any 2 to drop any variable. So I'm going to choose number 1 and number 2, and I'm going to drop z. Add. 1x and 2x is 3x. 2y and negative 4y is negative 2y. Negative z and z is 0 z's. And negative 1 and negative 11 is negative 12. Good. Now we've got an equation in 2 variables, an x and a y. Okay, I didn't get a double drop, so I didn't get to solve right here. So now remember, I'm going to pick any other two equations. So I'm either going to pick 1 and 3 or 2 and 3. And I'm going to drop the same variable. I dropped z's, so I have to drop z's again. So I'm just going to randomly pick these two to work with, 2 and 3. Okay, we're going to write those down. I'm going to write it way over here because I'm going to have to alter one of these. So I'm going to write these underneath. Yes, if I added them straight, my x's would drop. That wouldn't help me, because then I'd have one equation in yz and the other one in xy, and they don't go together. It has to be the same variable. Okay, so I got to drop my z's. Remember, I have to have the same number, opposite sign. So I want this to be a 5. So I'm going to multiply every single term here by 5. So 2 times 5 is 10. Negative 4 times 5 is negative 20. 5 times 1 is 5. And negative 11 times 5 is negative 55. Okay? And I'm not going to alter this one. I'm just going to leave that one alone. Plus 8y minus 5z is 13. Now if I add these, my z's go away, which is what I want. 10 minus 2, 8. Negative 20 and an 8, negative 12. 5 and a negative 5, gone. Negative 55 and 13, lazy, lazy, lazy. I don't care. Call me what you like. Negative 42. Oh, I could have done that one. It's getting toward the end of the day and my brain's fried. Okay, x and a y. X and a y. Doesn't that look like chapter or section 4.3? Yes, it does. So I'm going to bring these two together. Okay? 3x minus 2y equals minus 12. Did I say these were extra long? Yes, I think I did. So now I've got two equations with two variables, just like in section 4.3, and I have to solve these. So what do I do? Well, remember I have to have the same number, opposite sign. So if I multiplied this by a negative 6, it would turn into a positive 12, and it would do the trick, wouldn't it? So every single one has to be multiplied by negative 6, every term. So I'm going to alter that one. So I've got negative 6 times 3, negative 18. Negative 2 times negative 6 is a positive 12. I'm just attaching my letters. Negative 6 times negative 12 is a positive 72? Is that right? Like I said, it's the end of the day. Brain freeze 72. All right. And then I'm going to stack this one. Now, maybe I would have had to have altered that one as well. I got lucky and I didn't have to. Okay, now I'm going to add. Now, if I add these, my y terms are going to drop. So here I have a negative 10. Nothing here is equal to 72 minus 42 gives me a positive 30. Divide through by negative 10. Divide through by negative 10. X, I'm going to go over here. X is equal to a negative 3. There's one answer. It was a long haul just to get that one piece. Now, I'm going to go back to either this equation or this equation and throw my x in, and I can find my y. Okay, I don't want to go back to any other equations because I've got that z in there. It's going to mess me up. Okay, so I'm going to just randomly pick this one, and I'm going to put my answer of negative 3 back in here, and I'm going to find out what y is. Okay, so I've got 3 times negative 3, that's x, minus 2y is equal to negative 12. Okay, so I've got a negative 9 minus 2y is equal to negative 12. Add my 9. Add my 9. 9's are gone, so I've got negative 2y left on this side. Negative 12 and 9 is, what is that, negative 3. Divide through by -2, divide through by -2, and y is a positive 3/2 because a negative divided by negative is a positive. There's another answer, ick. That's all I can say about that is ick. Okay, so now I need z. Okay, so now I'm going to go back into any of the original 3, put in my x, put in my y, and calculate out my z, right? This is the easiest one because number 1, it's positive, and number 2, there's no coefficient in front, so that's the one I'm going to choose. So we've got I'm just going to write the whole thing out here. All right. I know x is -3. I know y is 3/2. Looking for z. Right? 2 times -3 is a -6. This is going to be a negative number here. I've got a negative and a negative. So 4 times 3 is 12 divided by 2 is 6. Plus z equals -11. That worked out well because this turned out to be a nice whole number. -6 and -6 is -12. And I've got to go up here. So I'm going to rewrite it for you so you can see it. And I'm going to add my 12 across. So z is 1. So there's my ordered triple. -3, 3/2, and 1. -3, oops, 3/2, and 1. Is that what I wanted to put in there? -3, 3/2, and 1. Fantastic. Okay, all your answers don't have to be nice and clean. They can be like this, messy, messy, messy. It's not going to be the most fun, but it is what it is. Look at all this work that we did here. Okay, we started here. Look at how many times I could have made a mistake. And it's very easy to make mistakes. So my suggestion to you is to keep things super organized, to write everything out and only do one thing at a time and label what you're doing so that you can go back and fix them. Because it's really easy to make mistakes on these. I mean, it's just incredibly difficult not to. Okay, so I'm going to erase all of this. Where's my home? There it is. And we're going to move on to word problems, everybody's favorite, right? That's not what I wanted to do. No, I need my pencil. There we go. All right. Okay. Yikes. All right. I don't even want to show you the answers down here. Okay? I want to show you how to do this without it. Because it is a multiple choice question and then we have to solve. But I want to do it without that first. So let's read it first. It says the largest angle in a triangle is 61 degrees more than the smallest angle. The sum of the measures of the two smaller angles is 6 degrees more than the measure of the large angle. We're supposed to let x, y, and z be the measures of the three angles from largest to smallest and write a system that works. Solve it and then check it. They're not asking for much, huh? All right, so picture. That always helps. Here's angle x, here's angle y, here's angle z. Okay? It's telling us that we're supposed to use these letters and it's from largest to smallest. So therefore, x is the largest, y is going to be the middle number, you know, its value is between, and z is the smallest. So we have to have that labeled before we can start using these words up in here. All right, so in word problems, 99% of the time, whenever you see the word is like equals. Okay, so I'm going to translate this first sentence into an equation. It says the largest angle in a triangle is. I stop right there. The largest is x, so I have x is. The word more than means to add. 61 more than the smallest. Well, the smallest is z. So I've got 61 more than the smallest. There's one equation. So now I'm going to translate this one. The sum of the measures, okay, what does sum mean? Addition. The sum of the measures of the two smaller angles is. I stop there. What are my two smaller ones? Well, I've got y plus z. The sum of my two smaller angles is. Is equals. More than, remember, is plus. 6 more than the largest, which is x. 6 more than x. Okay? Here's my second equation. I don't have a third equation. But I can go back in my brain and I can say, what do I know about triangles? What do I know about the sum of these three measures in any triangle? Well, I know that the sum of the angles in any triangle add to 180. Okay? So there's my third equation. The sum of all three have to add to 180. Okay? Good. Now what I'm going to do is I'm going to go back in here and I've got these. Okay, so these are x plus y plus z equals 180. That's one of our equations. And then this one's in alphabetical order with x positive, and this one's in alphabetical order with x being negative. So I've got to kind of move my stuff around so I can match them better. So my first one I have is x plus y plus z is 180. So I don't need to mess with that one. That one's set up correctly. This one, remember, we had a positive x and a negative z. So I'm going to take this equation here, x equals 61 plus z, and I'm going to subtract my z over. Okay? So then I would have x minus z is 61. Okay, so that's what they're looking for. X minus z is 61. There's my second equation. Now my third equation, remember I said I had a negative x in it, so I'm going to drag that over this way. Y plus z is equal to 6 plus x, so I want to subtract my x across both sides. So I have minus x plus y plus z is 6. So there's my third. Minus x plus y plus z is 6. So, okay, hang on, let me just drop that down one. Can I drop that down just a little bit? No, of course I can't. I can drop it down this way though. You can still see it. Here's my first one, that checks with this one. Then I have x minus z is equal to 61. That's this one right here and this one right here. Okay, so I'm eliminating a and b. All right, and of these two, which one matches? I have minus x plus y plus z equals 6, and that's this one down here. So I'm going to choose D. Nice. Now it's telling me, okay, now that you have your three equations, solve. Well, all right, I know how to do that. These are the three that I'm working with, right? What do? I choose any two and drop a variable. So I'm going to choose these two, and I'm going to drop my z term. Okay? So I'm going to write them out. X plus y plus z is equal to 180. Didn't I say these were long? I've got x minus z. Remember, I stack. 61. I can put a 0y in here if I want as a placeholder, so everything lines up nice and neat. And now what do? I add. X and x is 2x. Y and 0 y's is y. My z's are gone. What do I have here? I have 241. Right? 180 plus 61. I can always check that. I'm just going to check it because it's easier to check it now than if it's wrong. I'm not the best at adding and subtracting. If it's wrong, then the whole thing from here on out is wrong, and then I got to go back and fix it. So it's a lot harder to do it then. Okay, so what I did was I chose this equation and this equation, and I chose to drop my z's. So now I either have to work with this one and this one, or these two and drop my z's. Well, I think I'm going to want to work with these two and drop my z's. Okay, it's a little easier. So I'm going to go over here, and I've got x minus z equals 61. Scratch that. Let's put the placeholder in there. 0y minus z is equal to 61. And then I've got minus x plus y plus z is equal to 6. Okay, now look what's happening here. Now the reason I did this is to show you that things don't always work out. Okay? You can go down a path, and especially with matrices, you can go down a path and it gets to be such a mess and you can't figure it out. You got to start all over again. Sometimes you get the double drop when it works, and sometimes it doesn't. So we're going to see if this one works or not, but we're going to add these two. Okay, so we've got x minus x is 0 x's, right? We've got a 0y and a y for y. We've got a negative z and a z for no z's, and I've got 67 on that one. That one did work out. I thought it was going to not work out. Sometimes when you go down a path and you solve and everything drops and you get 0 equals 0 and you get nothing that works, and this is going to be in matrices, we're going to have to start all over again. Okay, so thank goodness this wasn't one of them. I thought it was for a second there. But what I did was I added my x's and my z's dropped. I'm adding, so now I can plug that back in here, right there, to find x. So this actually turned out to be pretty good. Plus 67 is equal to 241. So I'm going to subtract a 67. I can't tell you how many times I've had to start over in matrices. And we probably will. Okay, so now I'm going to use my calculator. 241 minus 67 is 174. And divide both sides by 2. But you know what? Starting over and making mistakes is the best way to learn. It really is. There is nothing that I have ever learned more from is my mistakes, especially math. Because I have to analyze, I have to look at it and go, okay, what went wrong? Why didn't this work? What would work? Okay? It's just a really good lesson. I know that it just really stinks when it happens to you, but then you got to start all over again, but you do learn a lot. All right, so now I can pick any of the three to find my z. I'm going to pick this one because I don't have a y in there, so it's a little bit easier. X minus z is 61. So I know this is 87 minus z is 61. I'm going to subtract my 87 across. This is gone, so now I have minus z is equal to a minus, what is that, 26? And again, I'm going to check that because I don't want to go through making things an error. Divide through by negative 1, divide through by negative 1. So z is, this is therefore 26. So let's check it. Let's check to see if these parameters are satisfied. First of all, do my angles add to 180? Does 87, 67, and 26 add to 180? If they didn't, they couldn't possibly be right. Okay, what's my largest angle? My largest angle in here is 87. Is that 61 more than my smallest? So if I took 87 and subtracted 61, would I get my smallest? Yeah, I do. And then it says the sum of the measures of the two smaller angles. Okay, so I'm going to add these two. Is that 6 more than this one? Well, let's try it. 26 plus 67 Is 93 6 more than this? Well, let's subtract 6 and see. Does it get to 87? It does. So you can check your parameters. Oops, that's not what I wanted. Either in here with numbers, or you can use the words. I like the words. Okay? If that's true, then we can put them all in. Okay, so what was my x? 87, 67, the brain of a gnat. The memory of a gnat today. 67, and what was z? 26. 26. Excellent. Check your solution. Yeah, we just did that. Okay, so you can either do it numerically or verbally, and I like the verbal. It's a little faster. Oh, one more, okay? This is not multiple choice. Okay, so it just wants the answer. So we're going to, first of all, put together our equations, and then we're going to solve. And we have no way of checking to see if the equations are right halfway through it, like in the other one. So we're just going to forge ahead. All right, perimeter. What does perimeter mean? We've got a triangle. The perimeter is the distance around. Okay, so it's this plus this plus this. Okay, so we know that the perimeter of a triangle is 48 centimeters. The longest side is 4 centimeters less than the sum of the other two sides. Twice the shorter side is 8 centimeters less than the longest side. Find the lengths of the sides of the triangle. Okay, for this one, it didn't specify what it wants as far as letters, so we can do X, Y, and Z. We can do A, B, and C. We can do whatever we wanted. And we're just going to say that this is the longest, this is the middle, and this is the shortest randomly. I could have gone in any order that I wanted to. So now we have to form 3 equations with 3 unknowns using an X and a Y and a Z. Okay, I could use LMS if I wanted to. The perimeter of the triangle is 48 centimeters. So we're going to translate that into a mathematical equation. The perimeter of a triangle is, okay? The perimeter is the distance around, is 48. There's one. This is your perimeter. X plus Y plus Z. Okay, let's use this second sentence. The longest side is, so we stop there. The longest side we've designated as X is. Then it says 4 centimeters less than the sum of the other two sides. Now whenever we have less than, that means subtraction, correct? So we want to take 4 away from what we're summing. Okay, so we're going to have to do the other two sides first. So we take the sum of the other two sides, and then it's 4 less than that. So we have to kind of go backwards on that. So the sum of the other two sides minus 4, or 4 less than the sum of the other two sides. And then the final one, it says twice the shortest side is. Well, the shortest side is Z, so twice the shortest side, 2 times Z, is 8 centimeters less than the longest side. Well, the longest side is X. So 8 less than the longest side. And there's my 3 equations. Okay? Now I can solve. So the first thing I'm going to want to do is I'm going to want to stack these. So I have my variables all lined up in a row. So, okay, so for this one, I'm going to want to subtract a y and subtract a z on both sides. I want to just get them over there, right? I want to stack. So I'm bringing these to the left. So I have the positive x minus the y minus the z equals a minus 4. There's my second equation. X minus y minus z equals minus 4. Ooh, double drop. Love it! Now this one, I've got 2z equals x minus 8. Let's see, if I dragged my x over this way, I'd be done, wouldn't I? Doesn't matter if it's negative or positive, but all I want to do is I want to stack my x, y's, and z's on the left. So I have minus x plus 0 y's right? Plus 2z's, just use that as placeholder, is equal to negative 8. There's my third and final equation. 0y plus 2z equals minus 8. Whew. All right, now I have to solve. So I want to work with these two and drop. I mean, actually drop two of them. So I've got x plus y plus z is 48. Do you see how long this is taking me? 40 minutes to do 5 problems. Ridiculous. X minus y minus z is equal to negative 4. And we didn't make a mistake, so think about it if they're not working out. Ah, yikes. Add. X and x is 2x. Y and negative y, z and negative z. You're out of there. 48 minus 4 is 44. Divide both sides by 2. So we have an answer. X is 11. There's one. All right. Now I can go back, just analyzing. I can go back to this particular equation and just plunk in 11 here, and I can find z. See how it's only got the double variable? It's only got the 2. So that's what I'm going to do. I don't want to go about this the hard way if I don't have to. 2z is equal to x minus 8. Well, I know what x is. X is 11. Sometimes you can't get away with this stuff. So 2z is 11 minus 8. Oh, are we going to get a fraction here? Yuck. Twice the shortest side is 8 centimeters less than the longest side. Well, that's going to stink. I didn't get that on my original one. So we have twice z is equal to 11 minus 8 is 3. So I'm going to divide through by 2, divide through by 2. So we have z is equal to 3 halves. Yuck! And now I want to find y. So I could use this one or I could use that one. Okay? So I'm going to plug in my values. Let's try x plus y. I don't think this is right. Good, we made a mistake. Now we got to go back and fix it. Where am I? 48. There it is. Sorry. Oh, I'm getting you dizzy. I don't think this is right. I don't think this can be possibly be a fraction, because these are all whole. So, well, let's just try it, but I don't think it's right, which is good. 11 plus y plus 3 halves is equal to 48. So we have y is equal to, okay, I'm going to subtract my 11 and subtract my 3 halves, both sides. I can do it this way too if I want. So we have 48 minus 11 minus 3 halves. See, now I had another one in here. I'm just going to do this on the calculator. Minus 1.5. So I'm going to get this 35.5. Maybe it's right. I don't know. 35.5. Now, my math lab is not going to like that, so we're going to want to do math enter, enter. 71 halves. What was I saying right before I did that? I don't know. So let's check it. I don't think this is correct. So, do they add to 48? Let's check it. 11 and 71 halves plus 3 halves. Well, it does add to 48. All right, the longest side is 4 centimeters less than the sum of the other two sides. What's my longest side? What did I say my longest side was? My longest side was x. So is x, where's x? Is this 4 centimeters less than the sum of these two? I should circle my, sorry, I should circle my y. Nice, I did it again. You know what I did last time? I was like, for some reason, bumped that. I don't know how the heck that button bumps it, but okay. The longest side, x is, okay, so we're going to add 3/2 and 71/2. We get 37. And the longest side is 4 centimeters less than the sum of the other two sides. No, that's not true. So we did make a mistake. Don't you love it? You probably know where it is. You probably went about 10 minutes ago, wait. All right. So what do? Well, this is what we do. We check. Okay? We go back, and I'm pretty sure that these are correct. Let me just drop this down just a little bit. Let's go back and check these. We have the perimeter of the triangle is 48. X plus y plus z is 48. We have the longest side, which we've designated as x, is 4 less than the sum of the other two sides. So I have y plus z minus 4. That's correct. That's right. So twice the shortest is 8 less than the longest. So I think I have my triangle set up correctly. This one transferred over. Then I'm going to check this one. I subtracted my y and subtracted my z, so I've got that -4 sitting over there. Over here I've got, I subtracted my x over, so this is fine. So I think I'm good up to here. Alright, so then what did I do? I took these two and I added them, right? So I had 2x, my y's and my z's left. I'm adding these for 44. I'm dividing by 2, which is certainly not 11. What? How did I get that? I have no idea. See, that's what we have to catch. Okay, so if x is 22, then we have to go back and we have to recalculate out y and z. Okay? 44 divided by 2 is 22, not 11. Whew! All right, but you probably knew that, right? So now I'm going to go back to this one. Where is my original here? I've got 2z is equal to 8x minus 8. Okay, so I've got 2z is equal to x minus 8. See, this is how you fix things. 2z is equal to 22 minus 8. 2z is equal to, now I don't trust myself, 22 minus 8. I knew that it couldn't be fractional though. That wouldn't make any sense. 14. Divide by 2, divide by 2. This is looking way better. So z is 7. So now I have a mess. I have x is equal to 22. I have z is equal to 7. And now I just need y. So I'm going to go back to that original x plus y plus z is equal to 48. I know x is 22, looking for y. I know z is 7, right? So I'm going to take and subtract my 22 and my 7 from my 48. So I've got 48 minus 22 minus 7, and I've got my y is 19. So now let's go back and check these. It's a pretty quick fix. But you know why? Because I was organized about keeping this stuff organized. I knew what was going on and I didn't skip any steps, so I could go back and I could really look at it. So let's do this. Let's add them up. 22, 7, and 19. 48. That's the first one. The longest side is at 4 less than the sum of the other two sides. So we're going to add those two. Okay, so we've got 19 and 7. 26, is that 4 more than this one? Yep, now it's working. And it says twice the shortest side is, which is my shortest? Twice this, so that's 14. So we're going to take twice the shortest side, so twice 14, is that 8 less than the long side. What's 22 minus 8? 14. This is 14 as well, so it does work. So here's my correct answer. So even though this took longer, dang it, come on, pen. And even though I made a mistake, I didn't say we this time, it's good to know how to fix things. It's good to make mistakes. Like I said, I've learned the most from my mistakes, and I make a lot of them, and so are you. So we've got the lengths of the sides from the shortest to the longest. Shortest is 7, then it goes to 19, and then it goes to 22. Okay? Wow. 5 problems took us almost an hour. So matrices is not going to be any easier, not going to be any shorter. So that's what we'll cover next time is 9.2. And good luck. Let me know if you're getting stuck. All right, take care.